Hello and welcome to another tutorial, and we're looking at the Java language basics. So far we've looked at variables, the restrictions are defining variables, how to deal with primitive types and arrays. We also had an in-depth look at arrays. We looked at the var type identifier. We said that it's used for the local type inference, so you can just throw in var instead of trying to figure out what the type of the variable is. And now we're going to look at operators in Java. So operators, now that you have learned how to declare initialize variables, you probably want to know how to do something with them. And we know that when you create variables, now you want to do something, right? Usually if you define a primitive numeric type, you usually want to do some sort of mathematical operations, and Java, just like any other programming language, supports the basic and familiar operations like addition, subtraction, multiplication, division, and then it has modulus operator, for example. So learning the operators of the Java programming language is a good place to start. And it's very easy, right? These are something that you already are familiar with. So these are not some sort of foreign concepts. Operators are special symbols that perform a specific operations on 1, 2, or 3 operands and then return a result. So let's create a new package here. Let's call these operators. And we're going to create a new class, demo or operators demo, and let's go and have a main method here. So operators are symbols. Operators are just are special symbols, and you're already familiar with most of the operators. Familiar operators are plus for addition, minus for subtraction, a star for multiplication, and division, this forward slash for division, right? And we also have like a modulus operator. This is for integer, the remainder. So I'm going to maybe put it here. You might not be familiar with this, you might not have seen this, but this is a remainder operator, or sometimes it's also called modulus. And that works with two integers, int1 modulus int2. This gives you the remainder, remainder of the integer division. So it's not the quotient, it's the remainder. So basically, if you have two ints, a, which is, let's say, 10 or 50, and b is 11, and we've seen this kind of compound assignment or compound initialization, and we said that you cannot use var here even if you intend the two types to be the same. Var doesn't allow that, so you have to explicitly declare the types, and the types should be the same. I cannot say int a equals 50 and then double b equal this is not allowed because of the comma operator, right? So if you want to do this, it's like these two are two different expressions or statements. You have to terminate the first one with semicolon, but because we are using comma, Java compiler assumes that all the variables you use in the compound assignment are the same type, right? So all variables must be the same type. That's the restriction here. And then we want to say remainder. How do I get, or maybe first quotient. So the quotient is a divided by b. And the way this works is that the Java compiler assumes or checks the types first, checks the type of the two sides first. And then if they are both int, so basically if both ints, then we get the integer division, which means it doesn't give you a floating point result, so it doesn't give basically decimal result or float result, right? So this is implicit, and be very, very careful about this concept. What happens here if you have two integers, if you are not careful, and this happens to many people, it also happened to me at some point when I was learning Java, that when you divide two integers, if you're not careful, then you end up with losing accuracy, right? You don't get a float result because Java compiler look at both sides. So if I do a sysout here, quotient, and then plus quotient. So this is going to give me 4, right? So 50 divided by 11, 50 divided by 11, we didn't get a floating point number, we got an integer for 4, right? And therefore we can also look at the remainder, which is a modulus b, and we terminate with semicolon. So this is a modulus operator, which gives you the remainder as I mentioned. So remainder, so sysout remainder of 50 over 11, and then remainder, and we get let's see. Okay, let's add some arrows here so that we see what's going on. So the quotient is 4 and the remainder is 6, and what it means is that, so if you're not familiar with the integer division, it means if I have integer 1 divided by integer 2, I get a quotient plus remainder, right? That's the meaning of division, and also applies to obviously floating points, but in floating points we don't have division. The quotient is just can have arbitrary number of floating or basically decimal points, right? So when you divide a floating point division, you don't really get a remainder when you get integers, because you force the quotient to be also an integer, right? Yeah, and then you also get a remainder, which is also a whole number or an integer. We can also mix types, like if we say long, obviously we cannot convert long to int directly, because if you divide two longs, the compiler assumes that the type is also long. And let's also go long here. Everything is still works fine, but now all the types are assumed to be long. So integer division also applies to byte, short, int, and long, right? All the integer types. It's not just for the int types, modulus, and integer division. Now if I want float, so let's go with var here and here, right? So var works fine here because the compiler can deduce the type on the right hand side. Everything still works. But let's say in order to, instead of having the remainder, I want the quotient to actually come out as a float result, right? I want to get the exact result, not the integer division result. So I have to explicitly convert one of these two, a and b, to float. Now usually when my typical approach with literals is always to add a decimal place. For example, instead of saying 50 divided by 11, I always say 50.0 divided by 11.0, or so always try to, as if you are focusing on the float numbers or double numbers, always add this dot. Otherwise, if you suddenly write 50 over 11, you suddenly get an integer division. So be very careful about that. And we can see, right? If I say 50 over 11, because we said that these are by default to the compiler, these are integer literals. And when you use the division operator with two integer literals, then the compiler assumes your intention is to do integer division, so you don't care about the remainder. Still 4, right? So if I convert one of these to float, suddenly I get the exact number, the floating point number. So if your intention is float, if your intention is float division, always use the decimals in your literals, because then you are very explicit in your intention for the compiler, so there is no confusion. But the good thing here is that var helps to some extent here, because now if I just convert one of these explicit to double, then I get the result. And note that when you do this, the way obviously the casting has priority, so casting has higher precedence over division, which means when I say double a over b, so let's try this. So var x1 is double a over b, right? What happens here is that a is first promoted or converted to double, and then we have a double or floating point number divided by integer, and this integer is also promoted to basically a floating point, which is a double, because a long can be converted to double. If I write float here, this works. Let's see, it still works, right? But obviously the number, the result is going to be float, so the compiler assumes float. If I write double, then we get a double result. When I use var, we get a double result. Now that's the nice thing. If you at some point you try to convert a to float and then do this, and at some point in the future you decide that, oh, actually I want to do double, if you don't use var, then you run into problem. You have to fix also the left hand side, because double cannot be implicitly converted to float. That's why var is relatively nice thing. It changes the type under the hood from float to double, but as long as you care about this, because these are local variables, you're good to go. So for local variables, try to use var as much as possible, because that helps with the, like, if you want to change the type at some point. Now what about x2 is instead of saying double AB, I could also use double A over basically A over double B. So I promote B, all right, semicolon, and then sys out x2. This also works fine. So you can promote any of the long variables or integer variables A and B to double. And what about var x3 is I do the division first and then convert it to double. So I have to get the result first and then convert it to double. So note the difference between this statement and, for example, this one. Here A is promoted to double first, and then it's a division between a double number and a long number, integer number. But here we do an integer division first and then cast it to double. So sys out x3. Okay, let's close this. So if I run this, as you can see, I get 4 float. So this is a floating point number. But then what happened here is that we first did the division, which compiler assumes that this is an integer division. So first integer division, and then conversion to double, and then conversion to double. So be very careful about this kind of integer to floating point. Now some programming languages like Python, they started, I think in Python 2, what they did was they did the same approach in terms of if you have int divided by int, especially for the literal, you get integer division. If you divide one of them is float, you get floating point division. So division was like Java, but I think in Python 3 what they did was they defaulted the division to float, and then they introduced a new operator, integer division, a slash. So they explicitly introduced a new integer division operator. Now obviously Java always tries to avoid introducing new stuff. That's why whatever they defined at the beginning and went into the Java language specification is still there. So they didn't change the meaning of the operators, because that can cause some break some of the old codes, and Java wants to be backwards compatible. That's one of their selling points, right? And but the way Java handles its division is very similar to C++, right? Obviously in C++ the compiler can do more implicit conversions. Java tends to be more explicit about what kind of conversions are allowed, right, to avoid any errors. As we explore the operators of Java programming language, it may be helpful for you to know ahead of time which operators have the highest precedence. So that's the concept of operator precedence, which means if you first of all, round brackets or parentheses always rule the highest precedence, which means anything inside the round brackets is going to be evaluated first. So operator precedence is about how the expression is going to be evaluated, right? Which means when the compiler, when this line of code is compiled, obviously this gets converted to a syntax tree or some sort of tree of tokens, and then the runtime knows how to deal with this. Actually it's a compiler, because compiler writes the bytecode and in the bytecode it says what to do, right? It tells JVM what to do. So JVM doesn't have to figure out what the source code was. I mean, JVM follows the instructions that the Java compiler puts out. So when we say a plus 2 times b minus x3 divided by 75, right? This is some sort of, and let's assign it to x4. The operator precedence. First of all, expressions by default start to evaluate from left to right. That's just the syntax is English language, and English language is always from left to right, right? So Java's syntax is English language. English alphabet, we read it from left to right, so it makes more sense to make it, the evaluation are in that order, from left to right. So the compiler looks at the tokens and operators. So the compiler first identifies the operators, plus, times, and minus. And then obviously anything between two operators is a token. Here A is a token, 2 is a token, B is a token, x3 is a token, 75 is a token. And then compiler tries to evaluate from left to right by first figuring out which operations have the highest precedence. We know that multiplication and division have the higher precedence over addition and subtraction. So the compiler evaluates these first, right? These two terms first. And then after that, plus and minus have the same precedence. So the compiler starts evaluating from left to right. And these plus, minus, multiplication, and division, these are called binary operators. Binary operators means you have a left-hand side and then the operator and then right-hand side. And the compiler left-hand side has to be evaluated first, right-hand side has to be evaluated first, and then when these two are evaluated, then the whole expression is evaluated, right? And then when we have a plus something minus something, a plus something is evaluated first, and then this becomes the left hand side of the minus operator, and then the right hand side was also evaluated. So eventually this whole expression is going to be evaluated in that order. So you can read about these operator precedences just on Google, in Wikipedia, or just go and look at the Java language specification. But Java, just like most programming languages, follows the same logical precedence that people always assume, like multiplication and division have the highest precedence, addition, subtraction have the lower precedence, etc. The operators in the following table are listed according to precedence order. The closer to the top of the table an operator appears, the higher its precedence. Operators with higher precedence are evaluated before operators with relatively lower precedence. And these operators can be unary, binary, or ternary. There's only one ternary operator, which is the conditional operators. There is only one ternary operators. Ternary means it has 3 operands, A, question mark, B, colon, C, which means check this condition A is a boolean, some expression that returns a boolean. And then this is like if true, go and evaluate B, else evaluate C. So this is a shorthand notation for if else statement. And usually it's a very concise, and sometimes it becomes very handy instead of just trying if else, etc., right? But really it doesn't make the bytecode. If you look at the bytecode, A question mark, B colon, C doesn't really make any difference with if you explicitly write the if else. And we can check that. So let's put everything here, def test1 or public static void test1. I'm going to put all this code here, and then I'm going to say var x1 is if 10, or let's define an integer, int a is 20, and then var x1 is a greater than 15 question mark 10 colon minus 10, right? And then another thing is var x2 or int x2 equals 0. Let's initialize this and then say that if x2 or if a greater than 15, we're going to say that x2 is 10, else we're going to say that x2 is minus 10. All right. So if I go and look at the bin folder of my project and look at the bytecode, let's open with the class file viewer. All right, let's zoom in a little bit, go full screen. So let's look at the main method. What do we have in main method? 20 is a literal. We push it onto a stack, and then we store it in an A reference, and then load it, and then we push 15. These are literals, so they have to be loaded into the stack of the virtual machine so that the JVM knows what's going on, right? So push this if integer compare, right, less than or equal, goes to line 14, which pushes minus 10. So here we are actually the condition is greater than 15, but the bytecode, what the compiler writes in the bytecode is actually says compare the integer, these two integers that are on the stack. One is A, the other one is 15. Compare them for not for the greater than, less than, equal. It's very interesting that we are doing greater than, but the compiler decided to actually do a less than equal comparison. This could be just because less than or equal comparison is more efficient than greater than operator. So it says that if this condition for less than or equal, so basically if A is less than or equal to 15, jump to line 14. Line 14 assigns minus 10, right? So it goes with this branch, and then x1 gets minus 10. Minus 10 is stored in x1. So again, it's very interesting. I recommend that every once in a while you look at the bytecode and see how the compiler writes the bytecode, because here we're doing a greater than condition, but the compiler actually wrote the integer compare less than or equal and jump to 14. And then go to, so we jump to 14. If A is greater than 15, we push 10. And then we go to line 16, which means now that we push 10, we store 10 in the x1, right? So the result of here up to line 16, it's going to be either x1 becomes 10 or minus 10. And then icons 0, we are loading this literal to the stack, and then we store it in variable x2, right? This is just initialization. Note that if I don't initialize this, then this is still going to work, because I believe what happens here is that I don't think the compiler would complain, just because we're not initializing int, but it's always recommended to initialize the values, your local variables, with the default values or whatever you want, right? All right, so we set that up until this line 16 of the bytecode. We're going to basically get the result and store it into x1, and then we load the 0 into the x2, and then I store 0. So this is initializing the x2, and then I load 1, right? Because remember, A is stored in the index 1 in the stack, and x1 is stored in the index 2 of the stack, and then we are loading the index 1 integer number from index 1 of the stack, which is A, right? A was stored in the index 1. So it's going into evaluating this expression. First, it has to load A and then push 15 to the stack, and then again it's going to do an integer compare less than or equal. So it looks like any greater than operation converts into less than or equal for some reason in the bytecode. And if it's A is less than or equal, we have to jump to negative 10. It says if A is less than or equal 15, jump to basically 31, which we push minus 10 to the stack, and x2 is stored in the index 3 of the stack, and then we return this, right? So if you look at this code, for example, this part, where we load A, and then we push the condition, and then we push 10, and then go to I store 3, this 19 to 34, and then from where we load all the way to this. These are pretty much identical. There is no difference, right? Which means these ternary operators that really and if you this ternary operator is exactly equivalent in explicitly writing an if-else statement. There is really no difference in the bytecode, because 3, 4, 5, 6, 7 lines of code, 1, 2, 3, 4, 5, 6, 7 lines of code, exactly the same. We load A, we push the 15, we do if integer compare less than equal, we do a less than equal comparison between two integers, A and 15, and then we either push 10 or do a go to, and then minus 10 or a store, right? Exactly the same. But ternary operator tend to be much easier in some cases instead of just trying to write if-else loop. So I recommend you start also using the ternary operator whenever it's easier to just write your entire if-else into one line. So this is exactly an if-else statement. So I hope you enjoyed this lecture. This was a brief introduction to operators. We will look more into the actual old operators that are provided in Java in the future lectures. Please stay tuned, and I'll see you in the next one.